Welcome to another class. Again, I am Mr. Toure. Today, we shall be looking at angles. First, we need to define angles and know what are angles and some of the properties of angles. And it reads, an angle is defined as the amount of turn between two straight lines that share a common end. Point. Angles are measured in degrees. The symbol used for degrees is a little circle. As you can see, that is the sign for degrees. And there's an example of two angles here according to the definition. These are two lines that share a common point here, or a common vertex here, and you can see the distance between them is the angle. Okay? This is the amount of turn from here moving upwards that forms the angle. Okay? And as we can see here, these two lines are from the same place, and the amount of turn from here wide open equals to 45 degrees. The amount of turn from the beginning here, they share a common point that is 45 degrees. Terms associated with angles. Of course, when we talk about angles, we will talk about vertex, the arm, the degrees. So here we are defining each and every term that is associated with an angle. A vertex. What is a vertex? The vertex of an angle is the common point where two lines meet. Where the two lines that form an angle, where they meet, is called the vertex. Where two lines meet is called the vertex. This is an arm, one line, another arm. They share a common starting point here, and this is called the vertex. And the arm of an angle or sides are the lines that make up the angle. We say the amount of turn that is made forms an angle, but these two lines that measure the turns are the arms. Okay? The arms of an angle or sides are the lines that make up the angle. These two lines make up the angle. It could be two or more, all right, depending on the amount of angle you have at some point. Now, degrees. The size of the angle is measured in degrees and usually denoted with a symbol, a little circle. That is the symbol. For example, an angle may measure 45 degrees. The small circle there is the sign of the degree, 45 degrees. Now here we have a protractor, which is a tool that we always use whenever we are dealing with angles. We have protractors in our set of mathematical boxes, mathematical little instruments that we use in class. In every set box, you have a protractor, a set square, and a tri-square. Here our interest is on protractor, and there is a picture of a protractor. A protractor is a tool that is used to measure angles. We use protractor to measure our angles. You put the mid of the protractor, place it on your vertex, and make sure the first zero is on the arm at the starting point, and that will the second line measures the angle. Okay? That is the space between the two lines. Okay? Now, naming angles. How do we name these angles? Whenever we have angles, how do we name them? Okay? There are different ways to name an angle. We use different ways to name an angle. There's not only one way to name an angle. One way is to use the symbol. This symbol here denotes an angle. Okay? Followed by three letters from the diagram below. You can see angle ABC. The first and the third letters indicate points of the arm. Okay? We have angle A, B, and C. The first letter represents an arm. The last letter, the third one, represents an arm, and the middle one, the letter in the middle is the vertex. It's where these two lines meet, the two arms where they meet, they form the angle. And the letter in the middle there refers to where the vertex is. So if you see angle ABC, you obviously know that the vertex is at A because the letter A is right in the middle. B tells you that's one arm of the angle. C shows you that's another arm of the angle. And A is the vertex, okay, where the two arms meet. The first and the third can be switched because they measure the same angle. Now here's an example of that. Example, angle ABC is the same as CAB. As we read before, the first and the third one could be switched, but where the vertex is still remains the same because the vertex doesn't change. The vertex still remains to be the vertex. As you can see in the diagram here, this arm is B, and this is C. Where B and C meet to form the angle is the vertex, which happens to be A. Okay? In naming angles, you can switch between A and C, sorry, B and C, but A remains in the middle because A represents the vertex where the two arms meet. We're still on naming angles. Another way, that's one way of naming an angle. We're coming to another way of naming an angle. Another way to label the angle is by using the symbol, the angle symbol, with the only vertex point. The angle would be called angle A, where the vertex is. As we said before, the vertex is where the two arms meet, which happens to be the angle. So the letter there could be used just to name the angle, say this is angle A, because it represents the vertex, and the vertex is where the angle is. Finally, the last way to label the angle would be using the angle symbol, followed by the letter or number between the angle. This would be angle X, okay? We can name them from the inside this time around, where the angle is. You can see the angle is named here as X. So if you have a diagram and then the angle is labeled as X, we can say this is angle, the angle symbol, and then X, representing, measuring the angle here, or representing the angle, the interior angle here. Okay. We are to practice naming these angles here. We can use our various ways that we discuss here to name these angles. Name all the angles, possible angles here shown in the diagram. All the possible angles here are shown in the diagram here. We can name this angle by saying angle ACB, or angle BCA, or just write angle C, because that is where the vertex is. We move on to the second one. This could be named as angle EDF, and it could also be named as angle FDE, but could also be named as angle 1, okay? Because the angle here is labeled as 1. The third one here could also be named as angle ZYX, also as XYZ, and could also be named as angle 1, because the interior angle here is labeled 1. The four types of angles. Here are the four types of angles. The first one we said is an acute angle. And this is a drawing of an acute angle. But we have to know what are acute angles. Why do we call such angles an acute angle? Acute angles are angles that are less than 90 degrees. They are less than a right angle. So any angle that is less than a right angle, from 1 to 89 or 89.9, they are all acute angles. so long it is not up to a right angle. Okay? And then we have number 2 as a right angle. This is exactly 90 degrees. No less, no more. Any angle that is exactly 90 degrees is referred to as a right angle. And it is denoted with a small square at the angle. Okay? You shall never see an angle be labeled as 90 degrees. Whenever it's a 90 degrees, this box here represents a 90 degrees. We have another type of angles called obtuse angles. Obtuse angles are angles that are more than 90 but less than a straight line angle, less than 180. More than a 90 degrees, that's a right angle, but less than 180 degrees. So therefore, obtuse angles lies between a right angle and a straight angle at 180 degrees. So the last one here, we have straight angles. Sometimes you call it straight line angles. This equals to 180 degrees. Nothing less than that and nothing more than that. Any angle that is 180 degrees, it is referred to as a straight angle. We've talked about acute angles. Here is an example and a definition of acute angles. An acute angle is an angle that measures greater than 0 degrees and less than 90 degrees. Anything that is more than 0 but less than 90 is referred to as an acute angle. And here is a good drawing of acute angles. This is 80 degrees. It is obviously more than 0 but less than 90. So we say the first diagram is an acute angle. We have 45 degrees, which is also an acute angle because it's more than 0 but less than 90 degrees. And our third diagram here is 30 degrees. 30 degrees is also an acute angle, an example of an acute angle, because it's more than 0 but less than 90 degrees. Here is an example of a right angle. A right angle is an angle that measures 90 degrees. Any angle that measures 90 degrees is referred to as a right angle. Nothing less than a 90 degrees and nothing less than more than a 90 degrees as well. Nothing more, nothing less. And there are some pictorial diagrams here that shows us a right angle. And we can find a lot of right angles within where we live, whether it's our homes, our classrooms, our playgrounds, our daily lives, wherever we interact, wherever we move on, we can give various examples of 90 degrees. And a typical example here is shown here. This is a window frame, okay? And all these angles that you are seeing measures 90 degrees, so they are all right angles. Okay? An example of a right angle is drawn here as well. That is 90 degrees, denoted with a box here, just to indicate that it is exactly 90 degrees. Obtuse angles. An obtuse angle is an angle that measures greater than 90 and less than 180. Any angle that is greater than 90, more than 90, but less than 180, that's a straight angle, it is called an obtuse angle. And here are examples and pictorial diagrams that represent obtuse angles. 155 degrees is an example of an obtuse angle because it's more than 90, but less than 180. 115 degrees is also an example of an obtuse angle. More than 90, but less than 180. There's a drawing, there's a picture here also that represents an obtuse angle. Okay? This is from a roof. A passage of water or whatever on the roof goes down through this pipe. And you can see this angle here is definitely more than a 90. Look at the stretch. But definitely less than a straight angle. So therefore, it is categorized as an obtuse angle. An example of an obtuse angle here in the angle here. Straight angles. Straight angles. A straight angle looks like a straight line and measures 180 degrees. It is half of a revolution, half of a total revolution. Okay? Or half of a revolution of a circle. This is an example of a straight angle here, which measures 180 degrees. And then we've seen marks on a highway. Okay? These pictures are all pictures of a straight line. There's a metallic bar by the roadside. And the roads are also marked with some straight lines within. And these are all examples of a straight line angle or a straight angle. Now here is an example of another straight angle. By definition, angle ABC is straight angle if and only if B is between what? A and C. As we can see, the angle B, so therefore this diagram could only be a straight angle if B is between A and C. Okay? The measure of a straight angle is 180 degrees. As we said before, straight line angles or straight angles measures at 180 degrees. Can you identify these angles below? Now we need to do some identification here. We have 6 different angles, and all these angles are different in size. Okay? So we have number 1. Number 1 is an example of an obtuse angle. As we can see, it is more than 90, but less than 180. So example 1 is an example of an obtuse angle. This is an obtuse angle. This is an example of an obtuse angle. Okay? Example 2, we can see it is less than 90, but more than 0. And that qualifies an acute angle. This is an example of an acute angle. Okay? Number 3 is a right angle. It's denoted with a small square at the right angle. So therefore we say this is a right angle. This is an example of a right angle. Number 4 is very obvious. It's a straight angle or a straight line angle. So therefore we know that this is a straight angle. Huh? This is a straight angle. Number 5 is an obtuse angle, just like very similar to a first example. And number 6 also is an acute angle, because as we can see, it is less than 190, but more than 0. So therefore, that one also is an acute angle. Now we have to identify the type of angles from the measures shown below. Number 1 is Number 1 is 180 degrees. If an angle has 180 degrees, we definitely know that this is a straight angle. This is a straight angle, okay? This is a straight angle, okay? And then we have 33 degrees. Number 2 is 33 degrees. 33 degrees we know is an acute angle. Number 3 is 90 degrees, and that is a right angle. Right angles measures to 90 degrees. 4 we have 177, which is more than 90 but less than 180. So therefore, that qualifies to be an obtuse angle. This is an obtuse angle. This is an obtuse angle. Number 5, 153 degrees. 153 degrees is more than 90 but less than 180. So therefore, that is also an example of an obtuse angle. As we said, obtuse angles are more than 90 but less than 180. The final one is 27 degrees. Less than 90 but more than 0. It falls into the category of acute angles. Number 6 is an acute angle, 27 degrees. It is more than 0 but less than 90. This is an example of what? A says an acute angle, B says an obtuse angle, C right angle, D reflex angle, and E I need help. There are 5 options, and the diagram here is a 45 degrees angle. Angle ABC is 45, or you can read, still you can say angle CBA is a 45 degrees angle. So we therefore conclude that this is a right angle, sorry, an acute angle, because it is more than 0 but less than 90, so it falls on the category of acute angles. Number 2, this is an example of which type of angle? This is a 90 degrees angle. The angle is angle ABC is 90 degrees, and we therefore say this is a right angle. Right angles measures to exactly 90 degrees. Here we have another example. This is an example of which type of angle? The angle spreads to 135 degrees, and 135 degrees is more than 90 but less than 180. The angles that we say are more than 90 but less than 180 are called obtuse angles. Any angle that is more than 90 but less than 180 is referred to as an obtuse angle. So therefore, the correct option here is option B. Another example here reads, an example of which angle? Acute, obtuse, right, straight, okay? As we can see, angle ABC is a straight angle, or is a straight line, and the angle measures here to 180 degrees. So therefore, we say this is a this is a straight angle, or a straight line angle. An angle that measures 90 degrees, exactly 90 degrees, is an angle that measures 90 degrees is always a right angle. Any angle that measures exactly 90 degrees is a right angle. Okay, so to qualify the statement to be a right angle, an angle that measures 90 degrees is always a right angle. It's always a right angle. Another question, question 6 says, an angle that is less than 90 degrees is what? Always obtuse. B says sometimes obtuse. C is never obtuse. And D, you might need help. An angle that is less than 90 degrees is always obtuse. That is not obtuse. Sometimes obtuse. It is never an obtuse angle. Any angle that is less than 90 degrees is called an acute angle. So therefore, this angle cannot be an obtuse angle so long it is less than 90 degrees. that ends the lesson. I thank you so much for your kind attention and see you next time.